Hi, everybody. We're
Today,
gonna make a dancing fire.
no. Today we're gonna use pH differences to split water into two. All you need is some batteries, crocodile clips and graphite, you need sodium sulfate and litmus powder. Now, we're gonna do a process called electrolysis. Electrolysis simply means just flowing electricity through a solution or a molten ionic compound to get something you want. Here, when I electrolyze sodium sulfate solution, it will actually turn the water into its components, hydrogen gas and oxygen gas. What happens here is that the paper will divide the two sides, and on the negative pole, the hydrogen atom on the oxygen water will be reduced to hydrogen gas. On the positive pole, the oxygen atom in water will be oxidized to oxygen gas. If you haven't seen a video on oxidation and reduction, click here for more info. So let's make our solution. Now, sodium sulfate is what I recommend a lot because of many reasons. For one, it has a neutral medium, so it's not entirely acidic nor basic. So litmus turns red when acidic and blue when basic. However, sodium sulfate is neutral, so it turns purple. After all, we want to see some color differences. Number two, it is safe, or at least relatively safe. Number three, it is not a halide salt, because if you use a halide like just table salt, it could liberate toxic halogen fumes, which is completely undesirable. Number four, it is not a strong oxidizer, so it's really safe. Number five, it is not an environmental hazard, so disposal will be relatively easy. Lastly, its solutions are colorless, so our litmus can have more effect on color. So here, let's prepare our sodium sulfate solution. No, that's litmus machine.
Litmus.
Want to pour in the sodium sulfate?
Okay.
Now here, the concentration does not really matter, but I recommend just dump it in like this. I'll do it.
How much?
Just a random amount. Because,
How much?
I think yeah.
Just stir it.
Seems like you added a bit too much.
Oh.
Yeah. Maybe the litmus won't dissolve some of it.
Okay. Now what are we gonna do?
Well, now that we have our sodium sulfate, let's prepare our solution of litmus. Well, litmus is poorly soluble in water, but it won't dissolve.
It looks like rain
Mm-hmm.
falling down the sky, right? With the luminance water equals to
Yeah.
litmus plus water equals
Litmus solution. Let's pour our solution into our sodium sulfate.
get purple.
Mm-hmm.
And what we're gonna do?
Sodium sulfate has a neutral medium, so its solution with litmus will turn purple.
And what with this? What are we gonna do?
Well, we gotta separate this
Paper.
with paper
For a long while?
Nope, not for long. Let's repair our battery. Why is it small?
With this, what's wrong gonna happen?
Well, it's gonna happen after we complete the circuit.
This side it will be red and this side it will be blue, right?
Yes.
Let's wait. Welcome back, everybody.
Did you enjoy it? The entire process takes about 20 minutes for you to see noticeable change. What happens here is something called a redox reaction. Once again, if you haven't seen the redox video, check it out over here. At the negative pole, electrons are given. So, the equation forms as 2H2O plus 2E minus equals H2 plus 2OH minus. As you should have seen in our acid-base videos, OH minus ions always create a basic medium. Litmus turns blue in a basic medium. And on the anode, which is the negative pole, hydrogen gas is also liberated.
Like red berry.
And on the red side, which is the cathode, aka positive pole, well, the water is oxidized, meaning that electrons are taken. The equation here is 2H2O equals O2 plus 4H plus 4E minus. Because H plus ions are invited to solution, the medium becomes acidic. On the cathode, the bubbles forming, if in case you haven't noticed, is oxygen bubbles, not the hydrogen.
And there's orange and light blue.
In other words, the electrolysis causes reduction on the anode and oxidation on the cathode.
And the orange is the acid and the blue is a base.
Thanks for watching and see you in our next chemistry experiments. Bye!
Subscribe and like.
And see you in our next upcoming experiments. Bye!
Bye. See you tomorrow.